Good morning, friends. Today we are going to start Maths 2, that is Geometry, lesson number 1. In Geometry, there are 9 lessons are there. So we start the first lesson, Basic Concept in Geometry. See the first here picture. Did you recognize the adjacent picture? It is a picture of pyramid in Egypt, built 3000 years before Christian era. How the people were able to build such a huge structures in old time. It is not possible to build such a huge structures without developed knowledge of geometry and engineering. The word geometry itself suggests the origin of subject. It is generated from the Greek word geo. Geo means earth and metria means measuring. So it can be guessed that the subject must have evolved from the need of measuring the earth, that is a land. Geometry was developed in many nations in different periods and for different constructions. The first Greek mathematician Thales had gone to Egypt. It is said that he determined height of pyramids by measuring its shadow and using the property of similar triangles. Ancient Indians also had a deep knowledge of geometry in Vedic period. People used the geometrical properties to build altars. The book Sulba Sutra describes how to build different shapes by taking measurements with a help of string. In course of time, the mathematician Aryabhatta, Varahamihir, Brahmagupta, Bhaskaracharya and many others have given a valuable condition to the subject of geometry. In first to 8, there are only maths subject is for you. In 9th standard, the maths divided into 2 parts, that is maths 1 is algebra and maths 2 is geometry. So let's start the first chapter, Basic Concept in Geometry. Let's learn the basic concepts in geometry, that is a point, line and plane. We do not define the number. Similarly, we do not define a point, line and plane also. These are some basic concepts in geometry. You already studied in 6th standard about the line, plane and points. Line and planes are sets of points. Keep in mind that the word line is used to the sense a straight line. Now we are going to start the first point, coordinate of points and distance. Let's first draw a number line. Take points on equidistance. Immediately 0. Here right side of 0 there are positive numbers that start from 1, 2, 3, 4, 5, 6 and 7. And to the left side of 0 there are negative numbers, that is -1, -2, -3, -4, -5, -6. Here we given some alphabets to the number. Zero means origin, given here alphabet O. Here the point D on the number line denote the number 1. So it is said that 1 is the coordinate of point D. The point B denote the number -3 on the line. Hence, the coordinate of point B is -3. Similarly, coordinate of point A denote a number -5 and E denote the number 3 respectively. The point E is 2 units away from point D. It means distance between D and E is 2. Thus, we can find the distance between 2 points on the number line by counting number of units. The distance between point A and B on the above number line, A and B, there are 2 units. So distance between point A and B on number line is also 2. Now let us see how to find the distance with the help of coordinate of points. To find the distance between 2 points, consider their coordinates and subtract the smaller coordinate from the larger. The coordinate of point D and E are the 1 and 3 respectively. We know that here 3 is greater than 1. So therefore, distance between E and D is 3 minus 1, that is 2. The distance between E and D denoted by distance between E and D. This is the same as we can write length ED. That is the length of segment ED. Let's see here how to find the distance. Distance ED is equal to 3 minus 1 is equal to 2. So therefore length ED is equal to 2. Similarly, we can write here distance DE also 2. Similarly, let's find here by using this figure distance CD. See here, coordinate of point C is -2 and coordinate of point D is 1. Here 1 is greater than -2, so subtract a small number from bigger number. So here 1 minus -2. 1, this minus become plus 2 equal to 3. So here length of CD is equal to 3. Also similarly, we can write here distance of DC is equal to 3. Let's see on number line. The point D is 1, 2 and 3. 3 units away from the point C. So distance between CD is a 3. Now let us find here distance A and B. See here, coordinate of point A is a -5 and coordinate of point B is a -3. Here -3 is greater than -5. So -3 minus -5. Now write down -3. This minus become +5. So here 5 minus 3, that is a 2. So distance of AB is equal to 2, that is length of AB is equal to 2, or similarly distance of, we can write here, BA is also 2. From these examples, it is clear that the distance between two distinct points is always positive number. Note that if the 2 points are not distinct, then the distance between them is 0. Remember this, the distance between 2 points is obtained by subtracting the smaller coordinate from the larger coordinate. I repeat it again. The distance between 2 points is obtained by subtracting the smaller coordinate from the larger coordinate. And the distance between any 2 points is non-negative real number. Let's learn a betweenness. PQ are three distinct collinear points. There are three possibilities are there. Let's see here this first figure. P, Q, R. In this figure, point P, Q is between point P and R. In this figure, point R is between in point P and Q. And in this figure, point P is in between R and Q. So in first figure, distance of PQ plus distance of QR is equal to distance of PR, because here Q is between point P and R. In the second figure, distance of PR plus distance of RQ is equal to PR plus RQ is equal to distance of PQ. And in the third figure, we can write here distance of RP or PR plus distance of PQ is equal to distance of RQ, because here point P is in between point R and Q. Then it's said to be here point Q is in between P and R, point R is in between P and Q, and point P is in between R and Q. So betweenness is shown is to here in the first figure P dash Q dash R, in second figure P dash R dash Q, and in third figure R dash P dash Q. Let's see the example on betweenness. Example 1. On number line, points A, B, C are such that distance of AB is equal to 5, distance of BC is equal to 11, and distance of AC is equal to 6. Which two points is between the other two? Here, which of the point A, B, C is between the other two can be decided as follow. First, here distance AB is equal to 5, BC is equal to 10, and distance AC is equal to 6. Which one is bigger here? Distance BC. So first write down here distance BC is equal to 11. This is your statement number 1. And let's remaining sum of remaining two sides, that is distance AB plus distance AC. 5 plus 6, that is 11. This is your statement number 2. So from 1 and 2, the sum of remaining two sides is equal to third side. So therefore, distance BC is equal to distance AB plus distance AC. As per the given information, the figure is like this: BC and in between there is point A. So therefore, point A is between point B and C. Let's see the question number 2. UVA are the three cities on straight road. The distance between U and A is 215 km. Between V and A is 140 km. And between U and A is 75 km. Which of them is between other two? Let's see first the given things here. Distance UA is equal to 215. distance VA is equal to 140 and distance UV is equal to 75. Here, which one is bigger distance? 250. Let's see here, distance UA is equal to 250. This is your statement number 1. Now let's see the addition of remaining two sides. Distance VA plus distance UV is equal to 140 plus 75. That is 250. This is your statement number 2. So here from 1 and 2, distance of UA is equal to distance of VA plus distance of UV. In this, which number is common here? V. So, as per the information, figure is like this. V is common, so V is between U and A. So therefore, the city V is between the cities U and A. Let's see the third example. The coordinate of point A on a number line 5. Find the coordinate of point on the same number line which are 13 units away from A. Let's draw first figure. Here point A is a between to any 2 points. So let's suppose here take a point T and D to the left and right of point A. The point T is a left of point A and D is a right of point A. At a distance 30 units. It means in this side the point A is on the number 5. So here 5 plus 13, that is point D is on point 18, and here point T 5 minus 13, that is on point minus 8. So here write down the coordinate. of point T, which is left of A, will be 5 minus 13 is equal to minus 8, and the coordinate of point D, which is right of A, will be 5 plus 13 is equal to 18. So therefore, the coordinates of point 13 units away from A will be minus 8 and 18. So also you can write here distance of, you can verify by using this formula, distance of TD is equal to, or sorry, distance of AT or TA is equal to distance of AD is equal to 13. We can verify by using this formula also. Distance of TD, here coordinate of T is minus 8 and coordinate of A is a 5. So in between minus 8 and 5 is a bigger number. So subtract smaller number from bigger number, that is here 5 minus minus 8. It will minus minus become plus 8. It's a 13. And distance of AD is equal to, here coordinate of point D is a 18 minus coordinate of A is a 5. 18 minus 5 is a 13. Here distance of TD and distance of TA and distance of AD are the same. So here this answer is correct. Let's see here fourth example. If A dash B dash C and length AC is equal to 11, length BC is equal to 6.5, then find out length AB. By using this information, A dash B dash C means point B is in between point A and C. So the formula is length AB plus length BC is equal to length AC. Now put here value AC 11, BC 6.5 and AB as it is, because we want to find out here length AB. Now here length AB is equal to 11, this plus 6.5, it become minus 6.5. It's come to the right side and it's become minus 6.5. So here 11 minus 6.5, 4.5. So here length AB is equal to 4.5. Let's see the example number 5. From the given information, find which point is between two others. If points are not collinear, state so. Let's see the first example. Distance RS is equal to 8, distance ST is equal to 6, and distance RT is equal to 4. In this between the information, which number is bigger here? 8. So we'll find out here distance RS is equal to sum of the remaining two sides is equal to the bigger number. Let's see it is possible. First, distance RS is equal to 8. That is the statement number 1. And then distance ST plus distance RT is equal to 6 plus 4, that is 10. This is your statement number 2. So here from 1 and 2, this bigger number is not equal to the sum of remaining two numbers. So distance RS is not equal to distance ST plus distance RT. So therefore RT and S are not collinear points. Let's see the next example. Distance xy is equal to 20, distance xz is equal to 11.5, and distance zy is equal to 8.5. Let's see from the given information here. Big number is a 20. So we'll prove that the remaining sum of remaining two numbers is equal to big number. So first, distance xy is equal to 20. This is your statement number 1. The remaining two numbers, addition of remaining two numbers, that is distance of xz plus distance of zy is equal to 11.5 plus 8.5, that is 20. This is your statement number 2. Now let's see here, distance of xy is equal to sum of remaining two sides. These two are equal. So here from 1 and 2, distance of xy is equal to distance of xz plus distance of zy. So by using this formula, the figure is, see, xy are the end points, and here The z is a common, so z is a between x and y. So therefore, point z is between point x and point y. Okay, write down. Students, today we are seeing the find out the coordinate points and their distance by using number line. Then betweenness, and here our part first complete. So your homework is solve practice set 1.1. Thank you and have a nice day.